Hello, we're back at it. Section 12.4. Now we're going to talk about, in statistics, the measures of dispersion. Kind of dispersion is how far from the center something is. Like if you, I don't know, spill a drink on the floor, the center of the puddle would be, of course, the center or the middle. How far away did the furthest parts of the spill get from the middle? Kind of is what I think of when I think of dispersion. There's a few different measures of it, but some of them are better. Some are more complicated than others also, but some are better than others because the first one we'll see is where they take the lowest data value and the highest data value and just subtract them. So if you have these values, there's two of them, and maybe there's a few more running around here. Boom, 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 boom. I'm trying to draw it so that most of them are larger values over to the right. If I just take the maximum value, say this guy, and subtract the minimum value, that's what we'll see is called the range, or how far apart the highest and the lowest values are. It tells you something, but a lot of times it's not really reflective of most of the data values. You can see here, if these are all data values, most of them are in the smaller circle closer to the maximum. And then involving the minimum, subtracting the minimum might give you the false sense that the dispersion, or how far apart all the values are, is wider for the majority of these values, when in reality that's only true for the smallest one. He's way over there, but everybody else is pretty large. So we'll kind of see what situations one would be better than the other. But let's get into it. Get kind of technical here. The measures of dispersion are used to measure the variability of data, including the spread of the data. Kind of a way to measure how close are the data values together. Are they all fairly close together like these, or is it more spread out like these over here kind of, versus all way? Yeah, how far apart are the data values from each other, from the highest, from the lowest, that kind of thing. That's the main idea here. And the first one is what we were kind of alluding to just in the first slide here. The range is the difference between the highest values and the lowest values. It indicates the total spread of the data. So again, that might be reflective of something interesting, but for certain sets of data, it's not really helpful. But that's all it is. That's the easiest formula in this whole class, or in this whole chapter probably. The highest data value, subtract the lowest data value, or in other words, the maximum data value, subtract the minimum. That's my favorite formula of all. I'll never forget that one for the rest of my life. And that would be called the range. Okay, not so bad. So here's an example. Let's determine the range of this data set. The amount of carbohydrates in grams of 10 different types of yogurt is given below. Determine the range of these data. So you got 29, 12, 26, 18, 19, 8, 9, 8 again, 9 again, 16. So I guess this one, they're not in order, of course. I just have to search for the largest and the smallest. I think between these data values, this looks like the maximum. The maximum is 29. It happened to be on the left, but of course it could have been anywhere. I just have to scan through all these data values. And I think the smallest is 8. So, and 8 occurs twice, but that's fine. I think that's the smallest, right? Yep. So my range would just be the maximum minus the minimum, or the largest subtract the smallest, the maximum data value, subtract the minimum. And probably you could do this whole example without writing anything down except the answer, right? You could have just said it's 21, and I would say that's fine. You didn't really have to show work for that one. So that would be your range, is 21. But this one, I mean, let's say that someone said, this is what I'm studying, the amount of carbohydrates in different types of yogurt, and then you couldn't see the data values, especially if there were a lot of them. There aren't too many here in this set, but if there were a lot of them, maybe you can't see them. But this is one way you could describe the range. Say, well, the range is 21 grams. That's a wide range from the highest to the lowest. There's 21 grams between them. That doesn't really reflect that kind of where the majority of them are. A lot of them are smaller numbers, 12, 8, 9. You know, those are pretty small. 16 is kind of in the middle, I guess. So that's the only problem with it. If a lot of your data values are kind of skewed to one side or the other, the range doesn't really tell you much about that. Another measure that's better but more complicated. That's usually the way things are, right? In real life, something simple, it's usually not as good, and more complicated things work better. The standard deviation, and I'm sure even if you know nothing about statistics, you probably heard that word before, the two words, standard deviation. It measures how much the data differ from the mean. Remember, the mean's your average that's right in the middle of all the values. It is symbolized with S when it is calculated for a sample, and with the Greek sigma when it's calculated for a population. So that's already hard to remember, I think, to me. So keep track. It's hard. Once we run out of letters in math, we start using Greek letters. Remember, mu is the mean, because they're going to just start using symbols here. And then S is your sample standard deviation. So if instead, like if let's say I want to study the entire population of the US, if I try to pull as many people as I can in the entire United States, that would probably, I'd be measuring with not S, but this letter mu. I mean, sorry, not mu. This one's mu. Mu, this is sigma. Just looks like an O with a little line on the top, sort of. Then I'd be using that for the standard deviation equals standard deviation for the population. And remember, the population is just the entire group that you want to study. A sample is just a piece of what you want to study. So if let's say I wanted to study the entirety of all the people in the United States and their opinion on something, a sample might just be the group of 10 random people. Let's say I just pick 10 random names from people in the United States off the internet, and then I try to call them and get their opinion on something or something like that. That would be my sample, but population is for the entire population. Or sorry, the sigma notation. Just all the letters and the symbols, that's probably one of the hardest parts of this stuff. Okay, now this looks complicated, but you won't have to do this on a midterm or a final, okay? This would be, usually you have some kind of technology calculate this for you. It's silly to do it by hand, but it's good to kind of practice. We're just going to practice today, and maybe in the homework, we'll do a little practice for it, just because that way we understand what it means. But in real life, you would never do this by hand. Yeah, and if there's one on the midterm or the final, I would make sure it's very simple with very few data values. Yeah, so there might be something like this on the final, but it would be very simple. Definitely not a big group of data values. So first thing you need to do is determine the mean of the set of data. Remember, the mean is just the sum. You add up all the data values and then divide by the number of data values. Recall mu, or the mean, is you add all data values, and then you divide that, whatever that is, by the number of data values. Number of, there we go. Okay. So first things first, if you already know the mean, then that's fine. You can skip on to next step 2. But if you don't know it, you have to go calculate it. We'll make a chart having 3 columns. First, data, and the first, just the data values, like if you're polling someone, oh, how many hours of television do you watch each week? The data would be the number of hours, like 5 for this guy and 10 for that guy and 12 for this girl, blah, blah, blah. And then the next would be data minus the mean. So let me see, maybe I'll make a little, because it's kind of hard to tell. I know it's not clear the way it's written there. We're doing our best there, but it would be like that: data in one column, and then just whatever the data values are, they can be in any order. It doesn't have to be highest to lowest. And then the next column would be data minus the mean. So whatever your data value is, let's say in this particular one, there's like a 5 or something like that. And then let's say the mean in this example is 7 or something. I don't know. This is just an example, just so maybe it'll make it easier to understand. Then data minus the mean, this particular data value is 5. Subtract the mean is the same for all the data values. So this whole column will just be full of whatever minus 7. Whatever this value is to the left in the left column, minus 7 over and over. So in this case, it would be -2. And then the very last column you want to do is you're just going to raise whatever you got in the previous column to the left, you're going to raise that to the second power. It's the data value minus the mean, which we had already calculated in the previous part of this row right here. And then you raise that to the second power. So it'd be, in this case, -2 is what we got for the data value minus the mean. I raise that to the second power and get 4. And then I just keep doing that for all the data values. Whatever this is, let's say 2, I would do that minus 7, because that's what the mean is for this particular example that has no context. Whoops, -5, sorry. 2 minus 7 would be -5, and then I'll raise that to the second power, because it's kind of like this step-by-step procedure you have to do, and it's nice to have all these columns just one at a time. First thing, I'm going to write my data value. Second thing, I'm going to subtract the mean from that data value, and then I'll square the result just easier to have this table of values and table of steps, so that way I don't make a mistake or something. All right, that's what they mean by step 2. Then step 3 is you want to list the data vertically under the column marked data. I kind of already assumed we were doing that, I guess. That's the first thing you want to do. Subtract the mean from each piece of data. So I only have 2 data values in my table, 5 and 2, but all of them, no matter how many there are, you want to write all those first and then do all the subtractions that you need to. Subtract the mean from each piece of data. So you can fill out that second column, and then you're going to square each of those values you obtained in the previous column to find the values in the third column, kind of like we showed for at least the 2 data values. And then we'll determine the sum of the data values in the data minus mean squared column. That's our last step. I'm going to take all the values in this last column. I'm going to add them together, and that'll be what I want, the sum of all those data minus the mean squared. Because that's what I'm really after. And that's how I think we'll see in a future slide here pretty soon that there's a formula for it. You could just do all this stuff in one formula, but it's so many steps and so many numbers. It's kind of nice to do it step by step. First, put the data down, and then subtract the mean from each data value, then square it. Once you square each of those data minus mean, then you add all the results, and then that'll be what you want here. All right, and then step 7. Oh my gosh, it's very long. But yeah, this if there's one like this on the final or the midterm, or the final, I'll let you bring a note card or something, a little 3x5 note card, so you can write all these steps on there. Divide the sum obtained in step 6 by n minus 1, where n is the number of pieces of data. So whatever you got, you did all those steps so far, you got some sum, you added all the numbers in this last column, and you got some number, let's just say, whatever, it's a sum number. Now I'm going to divide it by n minus 1, whatever, n is the number of data values you had to begin with. So, or in other words, the number of rows of this table, and then subtract 1 from that. Oh, and there's one more step. Oh my gosh. Last thing to do, determine the square root of the number obtained in step 7. This number is the standard deviation of the set of data. So that is a lot of steps. And that's why you can tell why people in real life, when they're doing statistics, they would never do this calculation by hand unless they're just bored or something. But this is how it would look if you did it with, if you wrote it out in a formula. It looks complicated, but the outer thing you do is the last step in that procedure. You square root, that's the very last thing. The step before that was to divide by the number of data values minus 1. The step right before that was to add all of the results from that last column. That's what this sigma notation means. It means add or sum. And then what are you adding? Right before that, we squared something. And what did you square? It was the mean subtracted from each data value. Oh my gosh. That's a formulaic way to write it, but probably easier to just write the steps out on a 3x5 note card for the final. All right, we're going to try to do this. Oh my gosh. Let's see, I'm going to need that formula in front of me so I remember all the steps. Big old square root, n minus 1 denominator, the sum of each data value, subtract the mean. Oh my gosh. Let's see, I hope I have a lot of room here. Well, all right. Oh Lord, let's see. First thing, I want to find the mean. Okay. The mean, well, I think I forgot to mention this earlier, but remember mu was the population mean. And if you don't have that, you're probably going to find x bar or x with a line above it. That's the sample mean. Okay, so that's what this formula is alluding to. You don't see a mu in that formula because this is just a sample. I'm going to find the mean. That was the first step that was outlined, mu. That's where I just add all the data values. I'm just looking above 17, 28, 32, 36, 50, 52. What's the next? 66, 74, 104, and then divide by the number of data values. How many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, I think. 1, 2, 3, 4, 5, 6, 7, 8. Okay. I'm going to go ahead and add those and then divide by 9. Okay, and I got 459. That's the sum of the numerator over 9. Let's see what that is. Looks like it's 51. Okay. A lot of times your mean won't be a nice round number like that. You'll have to, it'll be a decimal that goes on. You can round it. Probably you would be told where to round if you had to, but yeah, there's that. Okay. Oh Lord, here we go. I'm gonna make this table of data values and blah, blah, blah. Okay, just like it kind of described in the step-by-step procedure. First column is gonna be data. Just all my data values. Let's see, how many were there? There were 9 to begin with. I'll need a row for each one. Oh, here we go. I'm gonna try to make this long, kind of wider. Let's see, 1 data value, 2, 3, 4, 5. Let's see. Okay, 6, 7, 8, 9. All right, that looks good. What are all my data values? 17. It's nice that they put them in order, I guess. That's the least they could do for this problem. 28, 32, 36. Just reading them off from the numbers that they gave us. 50, 52, 66, 74, 104. Okay. There's our, that's just, so far I'm just kind of copying down what they gave me. Now I have to do a little bit of math, not too bad. The next column will be each of those data values that are to the left, subtract the mean. Subtract the mean, and mine, in this problem, my mean is 51. So I'm just literally going to take 51 away from each of these numbers. This will be 17 minus 51. And feel free to not even write that in your column. You can just write the result. You don't have to write 17 minus 51 is blah. You just write this number, negative 34. That's all. So, and then the same thing here, but now it's, this data value is 28. So I'm taking away 51 from that. Forgive me if I have to do this. I'm always paranoid I'll make a mistake if I try to do the subtraction in my head. So I'm going to write it out. 32 subtract 51 will be negative 19. I've got to remember these negatives. If I don't include those in my answer, maybe something's wrong. Okay, and then now I'm doing 36 subtract 51, negative 15. Now I got 50 subtract 51. I think I could do that one in my head, negative 1. Now I've got 52 subtract 51, that's positive 1. Now 66 subtract 51, which is the mean, would be giving me 15. I was going to say 5. Okay, what's next? Now 74 subtract 51 is, let's see, that would be 19. Okay, now we got, oh wait, no, 23, what the heck? Oh man, see, I'm losing it. And now about last one, 104. Subtract 51 is 53. All right. Whew. We got the first or second column done. Now we got really, this is the thing, I guess. If let's say this is on a test, maybe in the future you take a statistics class in college or whatever. If you just write, let's say this is a problem on your midterm or your final and it says, give me the standard deviation, and you go, okay, sorry. Yeah, standard deviation is blah. What if your answer is wrong? Then you get no credit for that problem, no partial credit. But this procedure, writing it down with this table of values, at least your instructor, when they get your answer, they're going to say, okay, it looks like they're wrong. That's not the right answer, but look at all the things they did right. They pretty much knew what they were doing, but they probably, I don't know, subtracted something wrong or whatever it is. So I'm going to give them a lot of credit because they obviously knew what they were doing. So that's a big part of math, is showing your work, because you get, even if you get the answer wrong, you get partial credit. So that's it. Anyway, I'm trying to talk you into doing this table and not just giving the answer. Now, last column of this table, I'm squaring all the data values. I'm just looking to the left. What did I find here? Negative 34. I'm going to raise that to the second power. Oh, that's going to be a big boy. 34. The second power, holy moly, is, and then this is similar to the last column. You don't have to write this part out, the whole subtraction on the previous column. You actually don't have to write this part out if you don't want to. You can just write the answer. 34 times 34 is 1,156. But it's kind of nice to have, because then by the time you might be seeing this later and you forget, how did we get that again? It's kind of nice to have the breadcrumbs to follow. Now I'm doing negative 23 squared. That's negative 23 times negative 23, 529. Holy shit moly. These numbers get big. And then we got negative 19 squared, 19 times, 19 times 19. Why can't I just type that in? 361. Now it's negative 15 squared. See how tedious this is? That would be the word I would use for sure. 15 squared, wait, what? 15 times 15 is 225. Now this one I can do in my head. -1 to the second power is just +1. I like that one. Same thing with this guy. +1 to the second power is just 1. Now I've got 15 to the second power. I can kind of not cheat, work smarter, not harder. Should be the same thing as -15 squared, which I did up here. I don't even need to write that out. And what was this? Oh, somehow I lost the 3 and the 23. This is supposed to be 23 squared. We actually did that up here. -23 to the second power is the same as +23 to the second power. So 529, 53, we haven't done that yet, huh? I have to actually use my calculator for that. 53 multiplied by itself is, 2,809. Holy moly. These are some big old numbers. Anyway, and all the stuff that I've written down doesn't really matter. I don't, it's just me getting to my answer. Now I want to add every number that was in that last column. So I'm going to add, you know, I'm going to highlight them just so we know kind of what we're adding here. Everything didn't matter. Everything we just wrote was to get us to this point. All these numbers that I'm highlighting, those are what matters. And then once I add them, the individual numbers don't even matter either. I just want to know the answer to their sum. Okay. Okay, let me add those guys together. I'm going to take a second. It takes a while. Okay. All right, I think I got an answer. I got 5,836. I think there's an answer on the next slide, so I can always check that way. Oh, if this is on a midterm or a final, I'd probably add those all again one more time just to be sure. So I think that was step 3 of that long process. Step 3, add all those results, and then step 4, am I getting these numbers right? Was to divide that number by n-1. Okay, let me think about what's n-1. N is the number of data values we had initially. And, oh, what's going on? N is the number of data values. And if I remember right, I think we had 9 data values to begin with. Is that right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, just making sure. Okay, I've gotten this far hopefully without making a mistake. I don't want to do something now. So it's always 1 less than the number of data values. If I have 9 data values, now I want to divide by 8. So I'm going, this number, the sum that I got when I added them all together, divided by n-1, which I found to be 8. Okay, what do we got? Divide by 8. And it's, anyway, I'm getting 729.5. Okay, and then the next step, oh my gosh, am I labeling these right? I don't think I'm labeling these right. I think this was step 2, this was step 3 to make this was step 4, I'm sorry. Step 4 was to make that third column, step 5 was to add them together, step 6 was to do the sum divided by n-1, I'm sorry, and then the 7th step, I believe, was now taking the square root of that number, square root of whatever this is. In this case, it happens to be 729.5. And that's not going to be a pretty number, but that's okay. This number is never pretty. The answer to this, yeah, is never pretty. It's about 20, that's about 27.01, depending where they want you to round, but I'd say that's pretty close to 27. So this, yeah, probably they'd tell you, we would be told, okay, oh my gosh, 27 is the answer. After all those steps, I forgot what I was even doing. Why was I doing that? Why do I care? Where am I? What was the problem even about? It was about money, I guess. Oh my gosh, what were we talking about? Oh, the prices of 9 stocks on the New York Stock Exchange determine the standard deviation. Oh my gosh, and the mean was what now? 51. So I think that what it really means is on average, the data values are 27 units away from the mean. That's kind of, I think, the idea. That's kind of what, yeah, standard deviation. So the standard deviation was 27 or thereabouts. That means something like that's what we're trying to measure. The average data value is about that many, 27 units. In this case, we're talking about dollars, so I guess it'd be $27, but whatever you're measuring, 27 units away from the mean, which in this case we found to be 51. So on average, all your data values are about 27 units from, that's pretty much the idea, is how far away is my average data value from the middle or the average? Let's see, we got the same things. I'm just gonna check. Are we doing everything right? I think this was our sum, huh? 5,836. Is that what we got? Oh, thank God. And then what do we do? Oh, and then it says alternately we can use the formula. I don't know. Maybe we can do that, huh? Yeah, let's just do it, huh? Let's see. This is a very short section, but I think it's mostly because the standard deviation is probably about where students stop understanding statistics. Just because the formula is so complicated. But just keep in mind that you will not be I wouldn't make you memorize the formula or expect you to do it all by hand without having something in front of you. For the final, you can bring a 3x5 note card with your directions on it. So we could use the formula. Let's see. Oh, because I don't know. You don't have to worry about the formula. Just some people, their brains click better with formulas. Some people click better with the step-by-step process. But it was the sum of all the data values minus the mean squared over n minus 1 square root of that. So we could have done that. It was, let's see. Oh my gosh, writing this is bad. I know that the square root and then n minus 1, the sum of all the data values, x minus, oh geez, that would be hard to write. I would have to calculate each of these, each data value minus the mean squared. That's pretty much, you pretty much have to like come up with that, all the numbers on this, the final column. Maybe you don't have a table to gather all your thoughts in, but you'd have to come up with those. Oh my gosh, let me see. I'm gonna real quick take a picture of all those so I can write them down here. But that's where I would be getting these, all those highlighted numbers from the final column. I'm gonna try to write those inside the square root here, and they're all added together. 1,156 was the first, the first x minus x bar squared. 529 was the next one. 361 was the next one. 225. Oh my gosh, not gonna fit. Plus 1 plus 1. There's the next two data values minus the mean squared. 529, 2809. Okay, so that's really kind of written out instead of a step-by-step procedure where first I do this and then I add and then I do this. That's where that's kind of what I had to do somewhere. Even if I didn't show it, I calculated each of those each of the data values minus the mean, which was 51 squared. X in this particular example, x minus 51 squared. I had to do that a bunch of times, 9 times in fact, right? Because there were 9 data values to find those numbers that were in the sum. Oh my gosh. And then okay, so first I had to add all those together. Apparently, if I had done this way, what was the sum of all those numbers in the numerator there? It was 5836, I think. 5836. And then I divide that by 8. And what did we get for that? It was before we square rooted. 729.2 squared. I haven't done the square root yet. 0.2. And then when I square rooted it, I got about 27. So what I just showed here just is really the same thing that we did earlier. It's just, I wanted to show it both ways, either using that 7-step procedure or doing the formula. Because yeah, some people I feel like it clicks better doing just a step-by-step process. Some people it kind of clicks better with the formula. I think whichever one you prefer, I would write it on my 3x5 note card and bring it to the final for sure. Just whichever one you like better. This one, the advantage of the formula is it's tighter and smaller. It doesn't take up a lot of space. I don't have to write as much. But if it's not as understandable to you as the step-by-step, I would just write those steps on my note card instead. What we did over here, the procedure they gave us up here, where is it? Yeah. Even you could just print that out and bring that to the final if you want. I don't know. It's up to you. Just print it, type it, write it out, whatever is easier. Either way, it's not a fun process. It's good to know how to do it though, because we always want to know what our calculators or computers are doing, because some of you might become programmers someday. We need someone to program the computer to do this. So that's my spiel for making sure you understand what's going on. But really, I don't want you to shy away from any industry that uses statistics. You would use a calculator or a computer to calculate that for you. Don't worry. This is just to learn it. It's good to do it, but in real life, you wouldn't really have to do it. All right, that's it. We'll see you in the next section.